Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today I will present the topic of absorption. But before we starting the presentation, I would like to introduce myself. My name is Ramadhana Akmal with student ID 2009. All right, let's go into the case. With case study, the implication of the under uncertain operating condition on the optimal design of multi-stage operation and environmental impact. This is my reference about the uncertain operating condition implication of multi-stage operation, optimal design, and environmental impact. And here is the reference. So we jump into the study overview. The first one is analysis of the multi-stage processes under uncertainty and focus on economic and environmental optimization case study about the evaporator and distillation column with the use probability modeling. This study analyzed the impact of uncertain operating condition on multi-stage process. The objective is to evaluate how variability affect economic and environmental performance. There is two main case studies are considered, namely multiple effect evaporator and distillation column. The approach integrated uncertain into system design to improve the decision making. Next is the research objective. The main objective of this study is to evaluate how uncertain operating conditions influence optimal system design. This include economic and environmental conditions. So in this case, the study compared the result obtained under nominal condition with those under uncertain condition, highlighting difference in optimal design choice. So there is 4 points here. First one is evaluate effect of uncertainty on system design. Next is optimize the total annual cost. Next is analyze the environmental impact or CO2 emission and compare nominal versus uncertain condition. Next is the gas absorption in air pollution control. The gas absorption is a mass transfer operation where gaseous pollutants are transferred from the gas phase into the liquid solvent. This process is widely used in industrial air pollution control system due to its effectiveness. So there is 4 points here. First one is definition of gas absorption as a mass transfer process with the role in removing gaseous pollutant from industrial emission. The next is application in chemical, petrochemical, and environmental system. And the last one is important in regulatory compliance and emission standard. It plays a crucial role in reducing harmful emissions such as SO2, CO2, and HCl from industrial exhaust gases. Therefore, absorption systems are essential for maintaining the environmental quality and meeting emission regulation. Next is the fundamental principle of the absorption. And there is 4 points here, the gas liquid contact and interfacial area. Next is driving force with the concentration gradient. And next is equilibrium relation with the Henry law concept. And the last one is mass transfer resistant with the gas and liquid flow. So absorption occurs due to the difference in concentration or partial pressure between gas and liquid phase. The driving force ensures the transfer of solid until the equilibrium is reached. So the mass transfer is influenced by resistance in both gas and liquid films, which can limit performance. Therefore, increasing contact and improving mixing enhance absorption efficiency. Next, we jump into the type of gas absorption. There's 4 points here. First one is physical absorption with no reaction. Next is the chemical absorption with the reactive. Next is reversible versus the irreversible process. And the last one is industrial examples. The physical absorption depends on solubility and it's typical reversible, making it suitable for gas recovery process. It is commonly applied in CO2 capture using physical solvent. The chemical absorption involves the reaction between a gas and liquid, increasing removal efficiency significantly. This method is widely used for acid gas removal such as SO2 and HCl in air pollution control. The absorption equipment. There is 4 point here. The first one can say like picket column, like random structure picking, tray column, like sieve, valve, and bubble cap, and spray tower and scrubbers, and also efficiency versus the pressure drop versus cost. The picket column provide a large surface area for gas liquid contact, resulting in high efficiency. With a relatively low pressure drop, they are commonly used in modern absorption system. The tray column operate using discrete stage, while spray tower are simpler but less efficient. Equipment selection depends on the process requirement, cost, and desired removal efficiency. Next, we jump into multi-stage absorption concept. With the stage wide separation improve the efficiency, multiple equilibrium stage relation and energy consumption, and the last one is industrial relevance. The multi-stage absorption enhances the efficiency by providing several stages where the gas-liquid equilibrium is approached progressively. Each stage contributes to future pollution removal. The increasing the number of the stages improve the performance but also increase the system complexity and cost. Therefore, the optimization is required to balance efficiency and economic factor. We jump into the key economic concept. There is 4 point here. First one is capital expenditure. Next is operating expenditure. Next is total annual cost, and the last one is energy consumption as a major cost factor. The economic evaluation is based on the capital expenditure and also operating expenditure, which together determine the total annual cost. Uh, and the capital expenditure is equipment size and configuration. For the operating expenditure is mainly influenced by energy consumption, particularly heat data requirement. Therefore, energy demand play a key role in the system optimization. Next, we jump the uncertainty modeling. The use of probability distribution function or PDF that normal distribution or symmetric and gamma distribution as Swigwet and also representation of real disturbance. The uncertainty in operation condition is modeled using probability distribution function. This function describes how process variables fluctuate. The study compared normal and gamma distribution, showing that asymmetric distribution can significantly affect system behavior and optimization result. Next, we jump the methodology approach. There is 4 point here of ranking apex over an uncertainty domain. Use the integral based on calculation, comparison between deterministic and stochastic design, and the last one is evaluation of flexibility. Next, in the case study one, and there is 4 point here. First one is multi-stage operation system, while the multiple effect evaporator is analyzed under both nominal and uncertain operation condition. And also, point number two is about the variable number of the effect. The number of the stage significantly affect the performance. Next is about the analysis under uncertain feed flow rate. With the higher number of stage reduce energy consumption and as heat is reused across a bag. And with the last point is energy requirement evaluation. It can lead to improve the efficiency in the system. So we need to evaluation about the energy consumption so it can improve the efficiency in the system and also the heat is reused across the effect. Next, we jump into evaporator result. There is energy and OPEX. There are 4 point here. The first one is external data increase with the flow rate. Lower stage require higher energy. Linear relation between the data and flow rate, and OPEX increase the under uncertainty. The result show the energy requirement increase with the feed flow rate and decrease with number of stage. This relationship is approximately linear. Under certain conditions, apex increases especially for systems with the fewer stage. This highlights the importance of flexibility in design. Next is the evaporator or TAC analysis. TAC includes the under uncertainty and optimal stage shift, gamma distribution impact, and flexible design advantage. The total annual cost increases when the uncertain is considered, especially with asymmetric distributions such as gamma. The optimal design shift the optimal design shift toward more stage, demonstrating that flexible system can reduce overall cost under the uncertain condition. Next, we jump into the case number two. Uh, there is 4 point here. The multi-stage separation system analysis of the number of tray simulation using process software and evaluation of refluctuation ratio and that is. The distillation column is analyzed to evaluate the effect of the number of stages on energy consumption and cost. The system showed typical optimization behavior. Reflux ratio decrease as the number of stages increase, result in the lower energy requirement and reduced operating cost. Next, we jump the distillation result or nominal condition. The OPEX decrease with the more stage. CAPX increase the linearly. TAC show the minimum point and optimal stage in identified. Under nominal condition, the total annual cost show the typical curve with a minimum value at the optimal number of stage. The study identified the optimal design at 16 stage, balancing capital and operating cost efficiently, effectively. Next, we jump into distillation under certain, and this there is 4 point here. Sensitivity to fit composition, nonlinear behavior, different response depending on the stage number, and also the importance of the uncertain modeling. The distillation system is highly sensitive to feed consumption composition change, showing nonlinear behavior under uncertain condition. The effect of uncertainly varies depending on the number of the stage, highlighting the complexity of the system design under the real condition. All right, I think that's from my presentation about absorption material. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.